My name's Shane Rogers. I work for Harrison Steel Castings. Today I'm gonna give you a little story about our use of edge in IoT, how we did it, how we kind of went, problems we had, the challenges, and let's go through a little story about us. A little bit about me. I've worked for Harrison Steel for almost 30 years, about 29 years now. It'll be 30 this year. I know where the bodies are buried. So, I mean, I've built this network. I've done pretty much, if you were here a couple years ago, I think Jeff talked about some old foundry stuff. We're an old steel foundry, just like that. We go back from 1906 is where our company started. So it's old school manufacturing. No idea what data was when I started. We had System 36s and we did green screens and ArcNet. So we've come a long way. So we're going to go through a little bit about that story. A little bit about Harrison Steel. Um, Founded in 1906, like I said, we were actually a national car coupler. We made uh, wheels for trains. So that's how this company started. Since then, we've migrated over to more highly engineered castings, mainly for the mining industry. Um, this is a little old, a little bit. This says 700,000 square feet under roof. We're about 900,000 square feet under roof now. So we have a fairly large facility. We make parts, like I said, for the mining industry from around 400 to, this says 18,000. We're about 22,000 pounds now. Our biggest casting is right around 22,000 pounds, about the size of this stage. And it's huge. And it's for the big D11 bulldozer, if you know any Caterpillar stuff. So um, we have a very, like I said, very large facility, and that's kind of where this kind of goes. And we talk about this. Our mission statement. Really, I just want to kind of touch on one piece of this mission statement. I mean, we continuous improvement, yes. Quality focus, yes. Data driven. There's where our decision was about 15 years ago. We were going to make data driven choices. So everything has to be decided by data. We don't make anything unless any choice is made unless we are positive that the data means something and there's an ROI behind that data. So a little bit about what we're going to talk about today. Data collection. All right, we all have data. That's where this started. The challenges, limitations that we had for this data collection. My solution, my proposed solution, the proof of concept for that solution, our benefits, what we saw, where we saved money, and we did save a lot of money, and where we're going to go in the future for this, because there's a lot more to come. Data, right? We all have it. Everyone has it. It's a paradox I like to call it data because just because there is data doesn't mean we should be collecting that data. Now, if you ask my OT guys, they want it all, right? Millions of points of data, they want it all. But there's a balance, right? We have to find that balance of where data means something and you're not just having paralysis of all that data. I mean, I tell you what, if I asked my OT guys, we brought them in, we had this big long meeting, and we're like, what do we want? And the list could have filled up, 1,000 spreadsheets because of all the stuff they wanted from data. And I'm like, let's back off. Let's do this in small steps. And that's where we started with small steps. Challenges. Oh my goodness. Did we have challenges? Like I said, huge facility, data everywhere now because IoT was now a thing where it wasn't a thing 30 years ago. It's now a thing. Um, so we had to figure out how we're going to figure out this network because I designed this network and it's unfortunate. I mean, I'm getting a little older up there now. I designed this network. No idea we'd ever have IoT everywhere. I was thinking we have PCs here, we have PCs there. We're just going to design this big ring around my company. That's all we ever need. We don't need anything else. So the original fiber installation that we had was designed to support only PCs, never IoT. So here's a little map of my facility. Kind of give you an idea. It's a little hard to see probably, but around the outside, you see a little green. That's the fiber, that ring that runs around my company. So, like I said, I started there. I actually did all the pulling of this fiber. I did all the terminating of this fiber. This was my job when I first started there as a tech. So, it's gone. And then inside the facility, there's no fiber at all. It's just outside ring. So, this thing, but all inside is where obviously, machine tools, robots, all this stuff. Big collar fuchsia stuff in the center there. That's our automated molding lines that we put in about, I think it's about 20 years ago. We put that line in. And we didn't even fiber that up because we didn't think we were going to need IoT off that thing. But guess what? IoT. All right, so I came to Scale and said, I have an idea. Let's put servers on the shop floor and start collecting data. And they're like, that's not what we actually started this with. This wasn't our idea for these Nook devices. I'm like, I think we can do this. And PLCs never had an idea of just talking to these little devices. So I'm like, well, I think we can adapt the software and we'll come up with an analysis to come up do this. And they're like, all right, let's do a POC. So here's a little POC I had. This is inside of a little teeny cabinet on the shop floor. That's actually clean, by the way. that's actually after I cleaned it so I could take this picture, but it's really not a clean floor. So we put this little cluster out there. We use Allen Bradley software, which Allen Bradley, I went to them, I said, here's what I want to do with this collection of data. Like, you can't do that. It needs to be in a data center. You can't have this in there. I'm like, well, I think we can do this. Let's put these on the little devices. Well, you can't run it on VM. I'm like, let me try. And sure enough, it works just fine. They don't necessarily support it 100%, but it does work great. So we put these out there. This is now a mini network. So we have, say, 5 or 6 machine tools. There's some SAN things and a few other things. All these are connected to a dumb switch that is backplaned to my network through a Cisco switch there. So we can VLAN those off. I have it segmented so that now there's no traffic crossing across from my data network, from my PLC network. It's completely separated, which was one of my big deals because I did not want all this PLC network traffic on my data network, because if you deal with PLCs, you know it's just constant chatter. So we put this out there. We ran it for about 3 months, and everyone was amazed on the amount of data I was able to capture. This will give you an idea, a little bit of our graphs that we now have for the data we're capturing. This is a 1 week graph, and we grabbed 3 million data points in 1 week. So to give you an idea of how much we're grabbing, and this little temperature data here, there's a little sand flow data here. So in molds, we pour sand into molds. Our molds are made out of sand, so we pour these in there, and so we monitor the flow of sand, because that's actually very important to know how much time the sand was actually pouring. It's recipe based, but then if there is a quality issue later, now we can go back and look at the data. Originally, the data was not live. Now we have this a little more live, and I'll go into a little bit of that here in a second. So the benefits of my solution, again, I talked about it, simplified our network requirements. Our traffic now is segmented. And security, I mean, I don't have to have any IoT now on the internet. They don't touch the internet. They're completely separate. So they can talk amongst themselves without having access to the internet. And in manufacturing, we have some problems. There's been a lot of ransomware attacks on IoT devices recently. We're like one of the highest targeted individuals in manufacturing right now, especially we deal with a lot of Chinese partners. So we have a lot of state attacks on us on a regular basis. So having IoT out there for me was a big issue. So I had to make sure this idea kept us from having to do that. Redundancy. I mean, we all know Scale's redundancy capabilities. These little clusters, I have had them fail. We are in a very hot environment. We have about 115 degrees Fahrenheit on an average in the cabinets all times. So we are running a very hot environment. In the summer, the furnace area where some of these are, just ambient temperature is about 130 degrees in the foundry. So it gets very warm. And cost. Cost was a big deal, and I'll go into a little bit of that here. So we decided about 10 years ago, when we're going to start working this IoT thing, we decided that we're going to rerun a whole new plant network. There's going to be a whole new fiber ring. We're going to put it so it can reach all these machine tools. We estimated about $350,000 to do this, and we were looking at about a 2-year implementation time. I went to them. I said, "Look, I can do these little networks throughout our facility, about $15,000 a location. I can have them done. I can actually have it deployed in a day or less. But configuring the IoT side of it takes a little more work. My OT guys have to get in there and do a lot of work on the IoT side." So we were looking at this, and I'm like, "Here's our cost. What you guys want to spend $350,000? You want to spend $15,000? We do that 5 times, we're still way off ahead. So my company was like, let's roll them, start putting them out. So we did, and I think this is our current facility map. So the circles indicate where the centralized portion of my scale Nook clusters are now. So you can see where I have these all through the facility, and I put the circles in there because that's about 300 feet radius. So that's about where I can Cat 5 to a PLC. So we have these now spread out through our facility, and we're starting to collect data from more than just what I showed you earlier with the sand. We are now looking at areas for, but it's really crazy. We're welders, so welding time is a big deal. So now we're actually monitoring weld time on how often he has his arc open, how often, how many voltages is he over ramping his welder. So we're pulling all this data now, looking at all these things from a quality standpoint. And we have future ideas for more than just quality. But right now we're looking at quality. We're looking at my OT guys, all they care about is OEE, right? It's all they want to know about is how long is the machine running, how often do we need to be servicing it. My cost guys, they want to know how long that welder is actually welding. So now I can charge my customer for weld time. So we're looking at all these different ideas for collection. Our left side, that's our machine shop. We have 6 5-axis machine tools in there. All of those we're monitoring time on a casting, time from a bit change, time from everything along those lines. And the top left one, those are all, there's some new robots in that area that we're now monitoring from a vision standpoint on the robots. We're grabbing the data from on the edge there. Future ideas. Well, AI obviously is, I heard Jeff say it, come out there. My CEO's come to me, he's like, we need AI. What do you want AI for? He's like, we just need AI because everyone's doing AI. I'm like, well, we have the edge. We can use our devices now. He's like, so explain to me what to do there. And I'm like, well, we have compute power now at the edge that can do some of the AI. So we're looking at vision. We're looking at machine learning from that standpoint. We're trying to come up with new ideas from IoT sensors. The idea from the welders, that's not out there. We're actually building that in-house to try to figure out how to do some of these. Ideas are out. I mean, once I started showing what we can do from data collection, everyone's going like, I want everything. Bring it all to me. And now I go back, that first slide, that's what do we actually need to do? What is the good data? What do we need to actually collect? But I'm now saving the company money. We are, you saw the 4 different implementations out there. $350,000 would have been probably a little more than that in today's world, but we're looking at $15,000, $20,000 per rollout, and we are getting real-time availability. At first, we were just doing BI only, grabbing all this data on these edge. We're shipping it back to the data center. They're doing the data collection area, but with the compute power now that we have there, we are doing live screens. People can pull up screens out there on the shop floor and see what's happening live now. Especially when it comes to temperature and stuff like that, because that has a lot to do with our quality side. So we are now working on saving quality time down the road by knowing what's happening up front and front half of the house. That's really my story in a nutshell.